Greetings, Math 3. Today we're going to be taking a look at equation solving of all different kinds. So getting into complicated equations. To do this, we're going to start right from the beginning and build our way up. Now you have to remember that equations really are very much like a video game. We have one objective when it comes to solving an equation. We need to know what value, or sometimes values of x, make the equation true. That's really our main goal from now through whenever you're solving equations, even as you get into algebra and algebra 2. But when we think about it in base terms then, if that's our objective, what is our goal? Our goal is to isolate the variable on one side. That's really the goal. That's what we're trying to achieve. So if you think about it, it's really very much like any one of the video games where you need to achieve some kind of objective. Like say, for instance, you have a building here and X lives in that building. Now, before you can get to X, there are a bunch of different obstacles in your way. All kinds of things that you have to take care of. Well, as you go to get to X, if you're fighting through this game, you're not going to target this obstacle first, because while you're trying to take care of that one, these other things are taking away your life force. So typically, you have to work your way from outside in. You got to take care of this one first, and then this one, and then this one, and then this one, and then you got to go into the building and see if there's anything inside there you have to deal with. Well, the same is true with a variable and an equation. We have to get rid of the obstacles, the things that are protecting our variable, and isolate it so that we can see what it equals. To do that, we can use a phrase. It's kind of a funny phrase, but it is a nous a loose. And what a nous a loose stands for is that our goal is to get all numbers on one side, all letters on the other side. Now in a video game, you've got different kinds of tools at your disposal. If you're playing something like Legend of Zelda, you might have different things, weapons, logic, puzzles you have to defeat. If you're playing something like a Call of Duty, you definitely have a weapons arsenal that you're working with. It's all the same. No matter what game you play, your character always has resources and tools to use to achieve what you need. So the resources and tools that we have when we fight to solve an equation are inverse operations and properties. These are the two things in math that give us the tools to defeat an equation. Now, inverse operations is when you ask yourself, what will undo a math of some kind? If there's an addition or a subtraction, what would take care of that? Properties are when you ask, what is true about numbers? Or what can you do that is the same? So what can you do in the problem that really is not changing what's going on in the problem? It might change the way it looks, but it's still the same thing. We're not altering it, we're not affecting it, we're just making it look different. So inverse operations are things like your add, subtract, multiply, divide, and as you get into higher levels, things like roots and squares and whatnot. Properties are things like the distributive property, the commutative property, the associative property. These are things that let us mix up our numbers and letters and put things together. So let's take a look then from base up of how we solve equations, and we'll look at all of our tools. We'll start with the one-step equation. I know you've seen this before, and you probably already know how to do it, and it's okay. We're just going to start from the very basic kind. You guys have been doing equations like this since you were little, only when you were little, instead of an X, you might have seen a little box, and you had to fill in the number that made that work. All we've done now is, as you've gotten older and more capable of abstract thought, we've changed this box to a variable. So our goal is to get this variable alone. Many people find it helpful to draw a line through the equal sign because it gives you a visual that you've got two sides to this equation, a left and a right. And in the world of math, you can do whatever you like to the left side of this equation, so long as you do the same thing to the right side of the equation. So I'm going to look here and I see that after my x, there's a -9. I need to undo the -9. That sounds like an inverse operation because I need to undo. So what is the thing that undoes subtraction? Well, that's addition. If I add a 9 to a -9, I'm going to make that cancel out. Since I added 9 to the left, I have to do the same thing to the right to keep the balance of this equation. Well, now these two make 0, so they're gone. I add down, and I get x equals 12, which is something you probably already knew just from thinking logically that 12 minus 9 is 3. Here's another one. This one says that -4x is 8. Well, two things side by side mean multiply. So that's really -4 times x equals 8. How do I undo multiplying? Multiplication is undone with division. Since I was multiplying by -4, I'm going to divide by -4. 8 divided by -4 is -2. Those are your one-step problems because it takes one operation or step to get the variable isolated. So you have all your numbers on this side, all your letters on the other side. Okay. So let's take it up a notch. Two-step. The one step is like the first level of a video game. Not a whole lot you have to do in order to win. Two-step says, now that you've gotten smarter, it's time to make you have to do more in order to win. This is where that video game thought comes into play. There's a 2 times the x and a +5. And we have to decide which operation to undo first. Well, remember, like the video game, we don't start with the object that's right by our x. We have to start with something a little farther away. So we're going to undo the +5 first. To undo +5, we have to do -5. Those cancel out. Now on this left side, I still have the 2 with the x because I haven't done anything to that 2 yet. -7 minus 5 is -12. Now I have 2x equals -12. To undo multiplying by 2, I divide by 2. And I get that x is -6. Let's do another one. If you'd like, you can go ahead and pause right now and try this one on your own, or you can watch if you just want to see. So first things first, I'm going to undo the subtraction first. So I'm going to add 1. Those cancel. I get -3x equals 12. Now I have to undo this multiplying by -3x, or multiplying by -3, not the x. n, that means I'm going to divide by -3. And 12 divided by -3 is -4. Remember, we can always check every one of these solutions by plugging it back into the original problem and seeing if we get a statement that comes out to be true. So let's check this one just so that we can see how that looks. I would go back to the original problem and I would put -4 in the x spot. And I would do my order of operations. And I get a true statement. 11 equals 11. Therefore, that must be the correct answer. All right, let's take this another step further. Let's take a look at equations that have like terms. I think about these equations as being something messy and I have to clean them up before I solve them. If you look, doesn't it seem like there's a whole lot of mess going on here? And if we think about this from the perspective of simplifying expressions, which we've been doing, this whole left side could get cleaned up. There are things I can combine together. So take a look and see, what is it you think we could combine? If you like, pause the video to do it. If you don't want to, you can just keep watching. Well, right here, I have a -5x and a -1x. If I were doing this with little drawings, it means we have that. -x, 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 -x. You have lots of negative x's. In fact, you have 6 negative x's. And if I look at my constants, remember from doing little drawings, +6 is like 6 little pluses, -3 is like 3 little negatives. Well, 3 negatives cancel 3 positives, and I'm left with only 3 positives. Once I've cleaned up all my stuff on this equation, now I'm back to a 2-step. And that's the thing. Every equation we do like this is going to end up back in the 2-step zone and then the 1-step zone. It's going to be very repetitive. And you're going to get very good at solving it because of that. So I'm going to subtract my 3. I'm going to divide by my -6. And there it is. And again, if I wanted to check, I could go back to the original problem. And everywhere I see x, I could put -3 in its place. Now I'm going to do my order of operations. That's 21. That's 24. And that's 21. And so it checks. Everything is good. All right, let's do another one. This one says, so far, we've always had our x's contained to one side of the equation. So it's always been a whole bunch of jumbled stuff with x and then number. But what happens if you now put things on both sides? Like this. This is where our a new solution really comes in. Again, drawing the line helps you see that this 4x is on the right side. This -8x is on the left. And this line is like a wall. You cannot add these two together. They're on opposite sides of a wall. You cannot combine them. The only way you can combine them is to bring one of them over the wall to join the other. It's up to you as to which one you'd want to bring over. But remember, if you want something to flip over the wall, it has to flip over its sign. So let's say I want the 4x to come over here to join the -8x. That's a positive 4x. The only way to flip it over the wall is if it goes to -4x. So I flip it means it's gone from the right. Negative 8x and negative 4x are negative 12x. Plus 2 is still there. And then don't forget that minus belongs to the 10, so it is also still there. And lo and behold, we are back to the two-step equation again. All of our letters on one side, all of our numbers on the other side. So we'll just finish solving this one out. And we get x equals 1. So this is our collection so far of different kinds of equations. Let's bring in one more. Before we bring this in, we need to introduce a property. You may have seen this one before, but just in case you haven't seen the distributive property before, let's just look at what it is and what it says. So the distributive property says, you have a number multiplied to a parentheses, and inside the parentheses, there's something going on with a plus or a minus. If we look at this visually, remember that multiplication says we have 2 of these. So if I have 2 of those, that's what the first one looks like in a picture. It's an X and 5 positives. That 2 says I'm just supposed to do 2 of those groups. So now if I add it all up, I have a 2 X's and I have a plus 10. Well, I'm guessing that if you look, you'll see there was a shortcut there that would have allowed us to jump from the original parentheses straight to the answer without having to draw the pictures. So if you think you got it, why don't you try this one and see if you can get the answer? You can pause and come back. All right, now if we look at this, originally, 2, 3, 4, 5, 6, 7, 8. That's what a group looked like. Let's deal with the 3 first, and then we'll deal with the negative. The 3 says I needed 3 groups. The negative says that when I go to write it down, I'm going to change everybody. So that's 12 X's right there. That's 24 negatives. What the negative 3 says is that when I go to write down my answer, I change their signs. I make this negative 12x and positive 24. If we look at that shortcut, if I rewrite this problem another way, here's another way you could look at it. That's negative 3 times 4x minus negative 3 times 8. So there's the minus from there, the negative 3. Well, negative 3 times 4 is negative 12. And negative 3 times 8 is negative 24. But whenever I have minus negative together, it's like the 2 just sort of form together. This one turns straight up and down and slides in. Minus and negative become plus. So this is distributive property. What happens now is that we can toss this as yet another obstacle, another puzzle to solve when solving an equation. So before I can solve this equation, I do need to get that x to be free of its parentheses. So I'm going to apply my distributive property. I'm going to write out what I really have, not 2 groups of x minus 9, but 2 x's and minus 18s. That helps me, so now it's back to 2-step form. I can now solve because now it's in a form I recognize, and I'm guessing you would be getting very good at. Once again, just so you can see, let's check this answer. I'm going to go back to the original problem, always the original problem. Order of operations says I have to do what's in parentheses first. Those are now multiplying. And bingo, I've got it. All right, your turn. I'm going to give you one. Why don't you go ahead and pause your video and see if you can solve this one. Come on back when you are ready to check your work. Okay, here we go. I'm going to first take care of this now. I know that 3 times 4 is 12x, but make it its opposite. I know 3 times 5 is 15. It was plus 5. I'm supposed to make it its opposite. So I have minus 15. To get rid of this minus 15, I'm going to add 15. And I get 0. And that is okay. 0 is a number. You don't have to worry if you get a 0. I can still finish solving. Can divide by that negative 12. 0 divided by anything is 0. So when 0 is on top, you're okay. As a quick side note, having 0 divided by a number, that's just 0. You're taking nothing and you're dividing it up among however many people, everybody gets nothing. But if you have nothing, a number divided by 0, that you cannot do. We say that is undefined. Okay, that's not allowed. All right. Then let's put it all together. Here's your final challenge. Let's see if you can solve this equation. It's got a lot in it, like super complicated. So go ahead and pause and see if you can solve this all the way down. You can even check your answer and see if it's right before coming back to see how the equation was solved. Good luck. All right, welcome back. First thing I'm going to do is I'm going to take care of this negative. Now, when I see something like a negative in front of parentheses, there's no number there. If there's no number in front of parentheses, you can always give it 1, the number 1. It then gives me something to multiply. So 1 times 3x is 3x. The negative makes it its opposite. 1 times 7 is 7, but the negative makes it opposite. All right, now it looks like I got some cleanup to do because I see that I have x's here and x's here. 3 negative x's, 2 positive x's. That's 1 negative x. And then I notice I have plus 7 and minus 3. So 7 positives and 3 negatives make 4 positives. Now I notice that I have x's on the right and x's on the left. You can do whatever you want here. You can bring the 8x's to join on the left, or you could bring the 1x and join on the right. I think I'm going to do that this time, just so you can see the difference. If I'm going to flip the minus 1x to the other side, it's going to flip to plus 1x. So let's see what happens when I do that. I end up with just plain 4 over here. And I get 9x and minus 5. So now I'm going to add 5 to both sides. It's a two-step equation that's kind of backwards. And I'm going to divide by 9. And I get 1 equals x. Well, 1 equals x and x equals 1 are the same thing. It's actually called the reflexive property of equality. So it's a property, but it just makes sense. If 1 equals x, then x has to equal 1. So this is your whole timeline, if you will, of equation solving from the easiest up to something more complicated. Now let's see what you can do with it.